Welcome back to Science Modernizers. Welcome back to this video. Today we are going to see a problem on mathematics, precisely trigonometry. Okay, so if let's get started with the question reading. Question says, prove that tan theta into 1 plus sec 2 theta is identical to tan 2 theta. A. Show that 1 plus sec theta times 1 plus sec 4 theta into 1 plus sec 8 theta is equal to tan 8 theta divided by tan theta. B. Deduce the value of 1 plus sec pi on 9 into 1 plus sec 2 pi on 9 into 1 plus sec 4 pi on 9 times tan pi on 18. C. Find the general solution of tan 4 theta divided by 1 plus sec 4 theta equal to 1. So let's get started. So you can pause this video and give it a try. So let's get started with the video. So the proposed solution, we want to prove that tan theta into 1 plus sec 2 theta is identical to tan 2 theta. Each time you want to prove trigonometric equivalence is like this. We have to make use of trigonometric identities. So trigonometric identities is what we use us to prove this. So to begin with, we know that sec 2 theta is 1 on cos theta. So we are going to express sec 2 theta as 1 plus cos theta. 1 on cos theta. So sec 2 theta will be 1 on cos 2 theta. And so this will mean if we rearrange what is in the bracket, we have that taking LCM, we have cos 2 theta plus 1 divided by cos 2 theta. So from there, we can simplify using the identities of cos 2 theta both in the numerator and denominator. We have three main identities for cos 2 theta. That's cos squared theta minus sin squared theta, 1 minus 2 sin squared theta, and 2 cos squared theta minus 1. So those are the three main identities which is found in your formula booklet. So if we simplify, we see that 1 plus 1 will definitely give us 2. So if we add, we have that tan theta into 1 plus 1, that will be 2 minus 2 sin squared theta. Then all of this will be multiplied by 1 on cos squared theta minus sin squared theta, which is still our cos 2 theta. Now we can factor out 2, and if we factor out 2, what will be left here will be 1 minus sin squared theta. Now in that 1 minus sin squared theta, we know from the Pythagorean first identity that cos squared theta plus sin squared theta is equal to 1. So 1 minus sin squared theta is cos squared theta. So from there, we can divide all through by the cosine squared of theta. So if we divide all through by cos squared theta, what we have is, this will be cos squared. If we divide all through by cos squared theta, what we have is cos squared theta divided by cos squared theta will be 1. Cos squared theta on cos squared theta here will be 1. Then sin squared theta on cos squared theta is tan squared theta. So what will be left on the numerator will be 2 tan theta times 1. So that will give us 2 tan theta divided by 1 minus tan squared theta. And definitely that's the identity for tan 2 theta as required. Now let's go to the E part, which says show that 1 plus sec 2 theta into 1 plus sec 4 theta into 1 plus sec 8 theta is equal to tan 8 theta on tan theta. So we are going to use the idea above in the above proof to show this fast as possible. The mark allocations were, this was about 3 marks, this was about 2 marks, 2 marks, and 3 marks. So that's how the mark allocations were. So here we are simply going to use the proof above. So what do we have? Let's prove that. So the first thing is, from the above we get that 1 plus sec 2 theta is equal to tan 2 theta divided by tan theta. Now what pattern do we observe? We can definitely conclude that 1 plus sec 4 theta, we see that if you have 4, it will be equivalent to tan 4 theta divided by tan 2 theta. So as we see from here, the angle is being halved at the level of the denominator and maintained at the level of the numerator. So that's the pattern that we are going to use. So it means 1 plus sec 4 theta we maintain, then we halve it for the denominator. So what do we have? This will be the identity for 1 plus sec 4 theta. So it's going to be tan 4 theta divided by tan 2 theta. You can prove that and verify the answer. And likewise, 1 plus sec 8 theta will be equal to tan 8 theta divided by tan 4 theta. So all of this is based on the proof above, which we saw about this, showing that this is true. Because from here, if we make sec 1 plus sec 2 theta the subject from here, you see that 1 plus sec 2 theta will be tan 2 theta divided by tan theta. So you see the angle is maintained on the numerator and halved at the level of the denominator. Exactly what we have done here, maintained at the numerator and halved at the level of the denominator. Okay, so with that we proceed by replacing that in our equation given. So we want to prove that this is equal to this. So we are going to use the left hand side to show the right hand side. So if we replace, we see that 1 plus sec 2 theta is already tan 2 theta divided by tan theta. 1 plus sec 4 theta is tan 4 theta divided by tan 2 theta, and 1 plus sec 8 theta will be tan 8 theta divided by tan 4 theta. Now if we simplify, you see that tan 2 theta and tan 2 theta we cancel, tan 4 theta and tan 4 theta we cancel. What will be left to be tan 8 theta divided by tan theta, and the proof comes out. So this is equal to tan 8 theta divided by tan theta as required. Now let's go to the B part. Now we want to deduce the value of 1 plus sec pi on 9 into 1 plus sec 2 pi on 9 into 1 plus sec 4 pi on 9, all of that times tan pi on 18. Now what do we know? From what we prove, or from the proof above, we saw that this is equivalent to tan 8 theta divided by tan theta. Remember, it's just 2 marks, so we just have to observe and see what happens. Now if we compare this, and this, comparing those two, what do we realize? We see that if I rearrange this proof, it means I can multiply all through by the tangent of theta, so that we should get something of this nature. If I multiply all through by the tangent of theta, we are going to have this times tan theta. And so what do we have? And that is equal to tan 8 theta. So from there we see that that's what we get. But what do we realize? If I compare, sorry, I wrote the same thing many times. So if we compare, this was not supposed to be this. Now if we compare this and this, what do we realize? That this our 2 theta will be equal to pi on 9. So if 2 theta is equal to pi on 9, it means theta will simply be equal to pi divided by 2 times 9, which is equal to pi on 18. So that's how I did to have pi on 18. Now we could also compare otherwise. What's the meaning of comparing otherwise? We could use just tan theta strictly the same. So we can just use tan theta. You compare this entry and this entry, so we deduce that theta is equal to pi on 18. Now since theta is equal to pi on 18, we get that 1 plus sec pi on 9, all that statement will simply be equal to the tangent of it. Since all of this, you see that all of this is just like what we have here. I'll copy that statement twice. So what we have here is 1 plus sec pi on 9 times 1 plus sec. Now at this stage, if we want to have sec pi on 9 here, it means initially, let me write it the way it was initially. So it's going to be sec 2 into pi on 18, that's pi on 9. Then that will be, the next will be 1 plus sec 4 into pi on 18, and the next will be 1 plus sec 8 into pi on 18, all of that times tan pi on 18. Now we realize that this is just like 1 plus sec 2 theta 4 theta, since our theta is already equal to pi on 18. So if we multiply all of this by tan theta itself, we are going to have tan 8 theta as the result, as seen as displayed here. So it means that this will simply be tan 8 theta of pi on 18, which will give us tan 4 pi on 9. So that is the answer to that. So you can punch on your calculator and get the exact value. Now C says find the general solution of tan 4 theta divided by 1 plus sec 4 theta equal to 1. So what do we have? We notice that 1 plus sec 4 theta is tan 4 theta divided by tan 2 theta. So I'm going to replace that in our equation which is given. I will replace 1 plus sec 4 theta by that information. So it means that 1 plus tan 4 theta, tan 4 theta divided by 1 plus sec 4 theta will be equal to tan 4 theta divided by tan 4 theta on tan 2 theta. But all of that is equal to 1. So we clearly see that the tangents of 4 thetas will cancel out, and so we will have that tan 2 theta will be equal to 1. Now for principal values, 2 theta will be equal to tan inverse of 1, which is pi on 4. So the general solution becomes 2 theta will be pi n plus pv, where n is an integer. So what we have is the final general solution, if you make theta the subject, will be pi n divided by 2 plus pi on 8. So where n is an integer there. So that is the general solution to this particular problem. So this brings us to the end of this video. Thanks for watching, and always remember, every reality has its end. Know your limits and excel above all. Thank you very much for watching, and see you in our next video.